Hello everyone, welcome to the 9th lecture in this online Node.js programming tutorial series from W3 Grads. In this video, I am going to tell you about the event loop in Node.js. So, let's get started. Node.js is a single-threaded, event-driven platform that is capable of running non-blocking, asynchronous programs. These functionalities of Node.js make it memory efficient. The event loop allows Node.js to perform non-blocking I/O operations, despite the fact that JavaScript is single-threaded. It is done by assigning operations to the operating system, whenever and wherever possible. Most operating systems are multi-threaded. So, they can handle multiple operations executing in the background. When one of these operations is completed, the kernel tells Node.js, and the respective callback assigned to that operation is added to the event queue, which will eventually be executed. I will explain this in detail, as we move ahead in this video. So, let's proceed further, and take a look at the features of event loop. Event loop is an endless loop, which waits for tasks, executes them, and then sleeps until it receives more tasks. The event loop executes tasks from the event queue only when the call stack is empty, that is, there is no ongoing task. The event loop allows us to use callbacks and promises. The event loop executes the tasks starting from the oldest first. Now, let's take a quick example of the event loop. I already have my Sublime text editor open, where I have already created a file named eventloop.js. This file is saved in the test folder in C drive. Now, I will write the first statement, console.log, and pass a string message as statement1 in double quotes. Then, in the next line, I use the setTimeout function. This function can be used to schedule code execution after a designated amount of time in milliseconds. Also, the setTimeout function accepts a function to execute as its first argument. The second argument is the millisecond delay defined as a number. So, I am going to give my first argument as function, parentheses, and curly braces. Then, within this function body, I will include a console.log statement, and pass the string message as statement2. Also, I will give the second argument to this function as 1000 milliseconds. After this, I will go outside this setTimeout function, and write a third statement, console.log, and pass the string message as statement3. Now, my program is all set to execute. So, I will go to the search bar, and type cmd, and press enter. This will open my command prompt window. Here, I will run my eventloop.js file. Since my file is in the test folder in the C drive, therefore, I will need to change the current directory first. So, I will first type cd // and press enter. Then, I will again type cd space test, and press enter. Now, my current directory is changed to test folder in the C drive. So, I will now write node space eventloop.js and press enter. You can see the output as statement1, then statement3, and at the last, the statement2. So, why this strange output? Well, let me explain you guys what is happening. Here, this first console log statement is pushed to the call stack, and statement1 is logged on the console, and the task is popped from the stack. Next, the setTimeout is pushed to the queue, and the task is sent to the operating system, and the timer is set for the task. This task is then popped from the stack. Next, the third console log statement is pushed to the call stack, and statement3 is logged on the console, and the task is popped from the stack. When the timer set by setTimeout function runs out after 1000 milliseconds, the callback is sent to the event queue. On finding the call stack empty, the event loop takes the task at the top of the event queue, and sends it to the call stack. The callback function for setTimeout function runs the instruction, and statement2 is logged on the console, and the task is popped from the stack. An important point to note here is that, even if the timeout was set to 0 milliseconds, then also, the statements will be displayed in the same order. This is because, although the callback will be immediately sent to the event queue, the event loop won't send it to the call stack, unless the call stack is empty, that is, until the provided input script comes to an end. Due to this process, the output that you received was not sequential. Now, let me explain the working of event loop in detail. When Node.js starts, it initializes the event loop, and processes the provided input script, which may make asynchronous API calls, schedule timers, and then begins processing the event loop. In the example demonstrated earlier, the initial input script consisted of console.log statements, and a setTimeout function, which schedules a timer. When using Node.js, a special library module called libuv is used to perform async operations. This library is also used together with the back logic of Node, to manage a special thread pool called the libuv thread pool. This thread pool is composed of 4 threads, which are used to delegate operations, which are too heavy for the event loop. The examples of such operations are I/O operations, opening and closing connections, set timeouts. When the thread pool completes a task, a callback function is called, which handles the error, or does some other operation. This callback function is sent to the event queue. When the call stack is empty, the event goes through the event queue, and sends the callback to the call stack. So, this is how event loop in Node.js works. Now that you know the working on event loop in Node.js, it is also important for you to know about the phases of event loop. The image shows the order of event loop operation. The first phase is the timer phase. In this phase, the callbacks scheduled by setTimeout function, or setInterval function are executed in this phase. Pending callbacks is the next phase. Here, the I/O callbacks deferred to the next loop iteration are executed. The third phase is the idle, prepare phase, which is used internally only. The next phase is the poll phase, which retrieves new I/O events. Another phase is the check phase, which invokes setIntermediate function callbacks. The last one in our list is the close callbacks phase, which handles some close callbacks. For example, socket.on, close. So, these are the different phases of event loop which we have discussed. With this, we come to the end of this video. I hope you have understood the event loop, and it's working well. So, keep learning, and I will see you next time. Until then, please do subscribe to our channel for more interesting and informative videos on latest technologies. Thank you for watching this video.